Hi everyone, can you please open up to page 25 of your student edition? This is for task 2.5, all for one, one for all. This is a solidifying understanding task. We're still going to be talking about Carlos and Clarita here. If you'll recall, they have a business and they're trying to open a pet sitting business, and that we've looked at a few different constraints. We've looked at startup costs, space, feeding time, and pampering time. Okay, we've looked at a lot of those more individually, and today we're going to look at them all together. Okay, so Carlos and Clarita have found ways to represent a combination of cats and dogs that satisfy each of their individual pet sitter constraints. So individually they've looked at the startup costs, individually they've looked at the space, individually we've looked at feeding time, and individually pampering time. But they realize that they need to find combinations that satisfy all of those constraints simultaneously. Okay, and we're going to start just by looking at startup costs and space. Okay, so oops, I missed part of it. Let's get that S in there. That looked at just startup costs and space. Okay, you have already written these inequalities. Okay, they're in section 2.2, so I'm not going to go over how to write those. Just note you have actually already written those. Okay, so our first constraint was for our startup costs. And that first constraint is saying that 32y plus 80x is less than or equal to, I can't do the actual less than or equal to sign, so we'll use that instead, 1,280. And we know that our space constraint is found by doing 6y plus 24x is less than or equal to 360. Okay, so if you want to know where those come from, please go back to section 2.2, because you wrote both of those in section 2.2. One was written on problem 7 and one was written on problem 8, and you have graphs of both of those as well. Okay, so that's on section 2.2. I'd also like to remind you that on these we're saying that x equals our number of dogs and y equals our number of cats. Okay, if you'll recall on our graph, our y-axis actually had cats and our x-axis had dogs. Okay, so that's why I'm using this. It was on the graph that I gave you showing that x was dogs on our horizontal axis and y was cats on our vertical axis. Okay, so the first thing I'm going to ask you to do here is I want you to find at least 5 combinations of cats and dogs, okay, that would satisfy both of the constraints. Okay, it's gotta work for both startup costs and space. You need to list the combinations below, plot them on the graph that I'm giving you, and you have to explain to me, so I'm expecting to see sentences written. How do you know these combinations work? Okay. So please don't forget this last sentence here, because if you don't have that filled out, if you don't have a sentence written, you are not getting full credit. Okay. Then for problem 3, you have to find 5 combinations of cats and dogs that satisfy one of the constraints, but not the other. Okay. So you have to list the combinations. Okay. Get the word list in there. Oops, missed the L. I always miss that first letter. Okay, list the combinations below, and you're going to plot them on the graph provided. Don't forget, that's going to be a new color. Okay, so now for each combination, again, each combination, you should explain how you know it works for one of the inequalities but not the other. Okay, so again, some type of explanation for each of those combinations. You're going to have 5 of them, so I'm looking for 5 short combinations here. Okay, the next thing we're going to do is we're going to be rewriting your system of inequalities for feeding time and pampering time. Okay, Okay, so we have feeding time and pampering time, and that can be found in section 2.4. Okay, so if you look back, you can kind of see where all those come from. But for feeding time, that constraint is 12y plus 20x is less than or equal to 480. And then we also have pampering time, and that can be found with 16y plus 20x is less than or equal to 480. Again, go back to section 2.4 if you're not sure where all that comes from, that's fine, but you need to look back at section 2.4 for an explanation, because at this point, kind of moving on. And just like before on the one up above, x equals our number of dogs and y equals our number of cats. Okay? You're going to do essentially the exact same thing as up above, but this time you are going to find 5 combinations of cats and dogs that satisfy all 4 of the constraints. So the space, the startup cost, feeding time, and pampering time. So you have to list the combinations below, and then in another new color, plot them on the graph, and you got to tell me how you know those combinations work. Okay? So please make sure you tell me how you know that they work. Then just like above, 5 combinations of cats and dogs that satisfy just some of them, but not all of them. Okay? And I want you to list the combinations below, plot them on the graph, and again, explain how you know some of the inequalities work for some, but not others. Okay? And let's move on down to problem 7. So on this provided resource page, the graph you've been plotting all those points on, you're going to shade the region in quadrant 1 that represents all possible combinations. So this set of points is referred to as your feasible region, since Carlos and Cleta can actually board any of the combination of cats and dogs represented in the points in this region without exceeding any of their constraints on time, money, or space. And then number 8, I want you to explain why is the feasible region restricted to quadrant 1 for this section. So I'm expecting sentences written here. Okay, so this is task 2.5. I'd like you guys to please get working on this. Remember your group roles. Someone's a facilitator, someone else is a timer, quality controller, and a reader. So please make sure you're using your group roles here and that you're all working together. That you don't leave someone behind, someone's not working ahead. You truly work together. Remember how you worked on that group quiz, and that's how you should be working on the task. Thank you.